All right, let's start with the solution to the same differential equation we had with part number 1. Although the original differential equation is in terms of the variables x and y only, but we came up with a substitution. That's the reason why we have this particular differential equation in terms of x and v only. Now what shall we do next is to separate. There's no other way actually. Shall I say this is going to be prescriptive, no? So that this may be integrable by logarithm and this by either power or inverse tangent. But basically we need to deal with one term at a time, no? We will consider this first because this is there is gonna be a part of this that can be combined with that later on. So since our target here is logarithm, in the numerator we need this expression. Why? Because this is the derivative of the denominator. That is a requirement in differentiating a quotient or in integrating a quotient that will end up with logarithm. Now you will agree probably with me that v is equal to 1/2 of 2 times v. So why 2v in the first place? As I've said, we need 2v there. So that if we multiply 2 to v, we need also to multiply in the entire expression with its reciprocal. Next, how do we insert 2 so that this entire expression will still be equal to v? Alright, so we were already convinced the reason why we need to write there 2v, no? It's really needed there. And the reason why we have 1/2 over there. So that when combined, multiplied, the result is still equal to v. As stated here, this is our original numerator. What about here? We need 2. We need 2. Now, why do we have 1/2 here? Precisely because we need to factor out 1/2 later on so that we're left with this expression which is needed in the numerator. Alright? So we need to write 2 and 1/2 because you have also 1/2 there. Now we need to factor that out later on. Alright. Now what shall we do in here? Alright? We need to subtract 1. Why? Remember, our original numerator is v. And this entire expression must also be equal to v, as you can see out there. But we only have to form this particular polynomial in the numerator. So we're about to do that. No? Now, remember that we have 2 there because that's needed. And 1/2 here is just secondary to the presence of 2 there because we need to factor out 1/2 later on as a common factor, leaving us with 2v plus 2 inside or as another factor of this entire expression. But the result of evaluating this one is equal to 1. Therefore, if this is 1 minus 1, this entire expression is equal to 0, while this one is just equal to v. So in other words, no matter how long this is still equal to our original numerator. So that's it. We have this expression and then we have this remainder out here. Alright, we are now ready to write this over there. Alright, so that's going to be the result. So remember, we picked this up from our result there above. But remember that this is still equal to v. That's very important. Now, this is a remainder. All you have to do is separate this from this entire expression and then combine that with that expression over there. Alright, let us examine the result. Remember that it came from the last expression we have there below. So we just factored out 1/2 here because we will now separate this one. This is a polynomial in general with a common denominator. Now, but however, Take note, this is an issue. Why positive over there? Now, the overall sign of this entire expression is negative. So therefore, this will become negative, but that one becomes positive. All right? Then minus. Now, this is what I'm telling you about a while ago. We may now combine these two because they are said to be similar, and at the same time, we have accomplished our mission. The presence of 2v plus 2 in the numerator, so that we will be able to integrate this as logarithm. Alright, that's going to be the result. The only changes you have observed probably is the result when you combine these two terms. There you are. And this is ready, logarithm of the denominator. What about this one? So that's going to be the next issue. Alright, the good thing about our denominator is the fact that it is a perfect trinomial square, which can be factored in this manner. Alright? And therefore, if that would be the case, if this is a perfect trinomial square, this one, then we can evaluate this using power. Otherwise, if this is not a perfect trinomial square, then it must be inverse tangent. Alright? And we can write that expression in this manner for a better view of the possibility that this can really be evaluated using power formula. So our differential equation can now be evaluated using integration. And ladies and gentlemen, we don't see anymore any derivative or differential. So that is the end of differential equation. And actually, to find for the final answer, we only have to convert this back to the original functions, to the original variables, namely x and y. So we will go back to the substitution by first probably simplifying this. Alright, by the way, why c sub 1? Because I have a feeling that we will be able to have there another constant, but still a constant, so that we will reserve c for the final value of the constant. Okay, another simplification is a property of logarithm. That is ln, or logarithm for that matter. We may place that up as an exponent. And this one can easily be simplified. Alright? Alright, that's it. That can be or may be simplified as simply equal to b plus 1. And by property of logarithm, that's the result. Alright, and this can still be written as, so this part, as I've said, is already algebra and logarithm. Right, we may simplify this by raising or by applying antilog and anti-logarithm, and we will come up with this result, wherein by property, what you call this, loss of exponents, that can be written in this manner, no? Because you have there the presence of, instead of c is e raised to c sub 1, which is another constant. Alright, that's the reason why I reserved c for the final value of the constant. But we're not yet through, because as I've said, this is not our variable. We need to do, again, the substitution. Alright, that is our only way out. And I'm referring to this substitution. So this time, it's payback time. We will solve for v, because we need to substitute here and there to do away with v. There you are. And then, again, algebra, simplify. We only have to express this, both of these, into a common denominator. So you can see they are the same. And your denominator is but x. See to it that this expression is still equal there. Y over x is y over x. X over x is 1. Alright, and you do the same there. And then simplifying further. Alright, that's it, ladies and gentlemen. I would like to thank you for watching this video. That's all for now. Thank you.